Sweet. All right, so we're picking up with 2.3. We've already started it. 2.3, remember, is looking at other properties of functions. We've already seen discontinuities as properties of functions, but in 2.3, we're looking at some of the others. We've already talked about functions increasing and decreasing, that is, open X intervals from left to right, where a function is going uphill, downhill, and the occasional constant through an interval. And now we're going to look at something that you did have in Algebra 2, but maybe not quite as detailed as what we're going to do. We're going to be talking about local maximums and local minimums and absolute maximums and absolute minimums, okay? So there's some pictures right here, but before we do that, I'm going to insert a page. I want to kind of talk you through it a little bit. This is me essentially deviating from my own notes. All right, so if you want to add a page, feel free to do the same thing. All right, so we're looking essentially for extreme y values, okay? Extreme y values, let's write that down. That's another property of local behavior. Now, what makes a y value extreme? Is it because it eats bold nacho cheese Doritos while drinking a Mountain Dew on a surfboard in Hawaii? Yeah, that would definitely be an extreme y value. So, yeah, that would. But also, what we're looking for is essentially high and low points on a graph on a certain interval. We call the high points maximums, which you can abbreviate max, and we call the low points, any idea? Mins, right. So we have max and min values, max and min values. And when we talk about max and min values, are they x values or y values? I just said they're y values. Yeah, they're extreme y values. They're extremely high or extremely low. So they're collectively, bless you, they're collectively called extrema. It's a math term. We like to make up terms sometimes. So if you hear extrema, that's just a plural way to say extreme y values. Whereas each of these individually are called extremums. These are extremums. It's kind of like alumnus is the singular, alumni is plural. Extreme mum, okay, extremum. So collectively extrema, individually extremum. Now there are two types of max mins. All right, the first type is going to be what we call local max and mins or relative max and mins. They are actually interchangeable. Local max mins, relative max mins, they're interchangeable. Okay, these guys, here's some characteristics. These guys are going to be the high and low points, or I should put high and low y values. I keep on emphasizing that the max mins are y values. So let's do the high and low y values on an open interval. Okay, that's important. On an open interval. The next characteristics is we can have more than one of each. More than one of each. So we'll define them first, and then we'll look at a graph, and I'll kind of show you what they mean. Local max, local mins are on an open interval, and you can have more than one of each. The other type would be going along with the word local, we would have the word global. It's a G. Here we go. Global, or to coincide with the term relative, we would use the term absolute. And I'm going to put those in parentheses. I'll say why here in a second. Max or mins. 1 second is up. So the global max is the same as the absolute max. But because I put them in parentheses, that means that you don't even have to say what type they are. So if I just said maximum value or max, you would then interpret it as the global max or the absolute max. You do have to then say, if you want to refer to the local max or the relative max, you have to say local max or relative max. Because if you don't qualify it, everyone's going to assume it's the global or absolute. All right? What's the difference between the two? Well, the global or absolute max don't have to happen on an open interval. So I'll say they can occur at an endpoint. Oops. So if you want to come back up here on an open interval, maybe we'll clarify. Let's add a little side note to the top there. When it says on an open interval, let's go ahead and say can't occur at an endpoint. Because if you have an endpoint, there is no open interval containing it. You can't go to the left or right. But a global extrema can occur at an endpoint. And I didn't spell endpoint correctly. I got rid of the D. Okay. And then, can there be more than one? No. There is no only one if it exists at all. So here's a real quick analogy. It may not be a good analogy. My wife tells me I'm horrible at analogies. But you have lots of local municipalities throughout the United States, right? And most of those local municipalities have a local maximum person, which we typically call the mayor, right? Or in some cities like San Antonio, the city manager, who's actually more powerful. But whatever. You have many local maximums throughout the United States. But if you look globally, and I don't mean like around the world, let's just keep it in the United States. If we look over the entire absolute United States, there's only one absolute maximum mayor, and we call that the President of the United States. So the absolute maximum trumps the lower or the local maximum, right? Yeah, right. So we can have several local or relative max-mins, but we can only have one, if it exists, global or absolute max-min. So here's a little example before we get back to the notes in earnest. Let's draw this little function right here. Let's look on the interval from A to B, okay? And I'm going to use a lot of letters here. So let's put a solid dot right there, and let's go up to a high point, come back down to a low point, and come back up to a high point right here, okay? So let's go ahead now and label these other places on the graph. Ooh, well, I'm going to change that here, sorry. We all have iPads, so we could do that. We come down, and we'll go up, and then we'll come down, and we'll finish right here. There we go. So I'm going to label that high point as C. I'm going to label that next low point as D, and I'm going to label that next high point as E. So now I have these labeled. I can refer to them. All right, now let's go ahead and label the Y values that I'm going to be referring to, so we don't have to just say, hey, you. We can say what letter it is. Let's label this low point, A, B, C, D, E. We'll label that as F. The next point here, the end point, we'll label as G. Then the next point we'll label as H, and then we'll label this very high point I. All right, so they kind of go like this all the way across. All right, does that make sense? So we have the ordered pair A, comma. Ooh, I need to label this one. Let's label this low point as J. Might as well. So we have the point A, comma J. We have the point C, comma I. We have the ordered pair D, comma F. We have the ordered pair E, comma H. And then finally, the right endpoint is the ordered pair B, comma G. All right? So if you look at this graph, if I just ask you how many local extrema or relative extrema does it have, that's me asking you how many local maximums or local minimums do you see? What would you say? Local maximums? For all practical purposes, local maximums for continuous functions are going to occur on the hills. And the local minimums are going to occur in the valleys for continuous functions. So how many hills and valleys do you see here then? 3, right? 2 hills and 1 valley for a total of 3, right? When I say extrema, I mean maximums or minimums. So there should be 3 local extrema. All right, let's go ahead and list them. We'll go from left to right. This guy here is a local, we call him a local or relative maximum. Now, maybe in Algebra 2, you listed them as ordered pairs. Someone last period brought that to my attention. You listed them as ordered pairs. We're not listing them as ordered pairs. We can list coordinates, but we're not going to list them as an ordered pair. We have a local maximum of y equals I at x equals, the location is C. All right? That's how we list it. Now, here's why it's a local maximum. Notice I said it has to occur on an open interval. The true criteria is this. If you look immediately to the left and immediately to the right, do you find values that are lower than that? And the answer is yes. So that is a local maximum value. Now, the maximum value is the y value. It occurs at the x value. So why not list it as an ordered pair? That was the question that was asked last period. Well, what if we were measuring temperature in degrees Fahrenheit on the y-axis, and we measured time in clock hours on the x-axis? You wouldn't say that the maximum temperature of the day was 12 hours, 102 degrees, would you? You would say the maximum temperature was 102 degrees, and it occurred at 12 o'clock, right? That's how you would read it. So the maximum value is the y value. It occurs at an x value. Let's go to the next one. The next one, over here. There's another hill right there. So on that one, we also have a local or relative maximum of, whenever you say of, that's going to be a y value. So of y equals h, and it occurs at x equals e. Now, again, it's a local max because the criteria is if you look immediately left and immediately right, you see values on either side that are lower. So those would be like the two municipalities. They are both king of their respective hills, right? And they don't interfere with each other's municipalities. He's the local max of his hill. The other guy's the local max of his hill. Do we have a local min? We do, right down here, okay? This guy's the king of his valley. So this is a local or relative min. You can see I tend to use local instead of relative. A local minimum of y equals f, and it occurs at x equals d. All right, local minimum of y equals f at x equals d. And that takes care of all three of the local mins and maxes, right? Those are the hills and valleys. Now look at over here at the point a comma j. Would you say that that's also a local minimum of j at x equals a? Not the way I gave you the definition, no. Someone might be able to make an argument that in the vicinity, in the relatively small interval of a, j is the lowest point. But remember that local extrema have to occur on an open interval. So if you look immediately to the right, yeah, I see values that are higher. But what do you see if you look immediately to the left? Nothing, okay? So that's why local extrema have to occur on an open interval. There has to be a graph to the left and right. It can't occur at an endpoint, all right? Whereas global extrema can. So let's go ahead now and look for global extrema, or absolute extrema, or just extrema. When I say what is the absolute max or what is the global max, I'm asking on this entire graph, is there a single y value that is bigger than all the rest everywhere else? And the answer to that is I is the biggest y value. So the local maximum is also the global maximum. And I'm going to put that in parentheses. So we have a global maximum also of y equals I at x equals c. All right? So again, I could just say maximum of y equals I. So we can have the local max also being the global max. Is the other local max also the global max? No, because there's obviously y values on the graph bigger than he is. But the reason we call it a relative max is because, again, if you zoomed in on this relatively small interval, he's still a high point in that local vicinity. All right, so now do we have an absolute or global minimum value? Yeah, the global is always the highest point on the graph. And it can only be one value if it exists at all. It could occur at several locations. Like if I had another peak that went as high as I, we could say the max is still I, but now it just occurs at two different x values. But you can only have one y value that is a max. And just like min, you can only have one global min. Is there a y value that's lower than all the others on that interval? J is the lowest y value. So J, although it's not a local min, it is a global min. We have a global or just a minimum, if you want to say it that, of y equals j at x equals a. Good. So global extrema can occur at an endpoint, whereas local extrema cannot. And so there's a couple of differences between the two, and definitely now the way we list them is different than what y'all are accustomed to. This is how I want you to list them. The minimum or maximum of y equals, and then at x equals, all right? Cool. There you go. Let us then, we could skip this part because we've already done that, so we'll skip this. My graphs did a better job of that. Okay, so here's where we're going to use the calculator on example 3. Using the calculator now, we're going to find the coordinates of all the relative extrema, and we'll add to this and the absolute extrema. We'll do both of them. So again, the terminology is relative and absolute, or you can use local and global, or just local and nothing, okay, for the following functions using the graphing calculator. So here's what you do first. Grab your calculator, hit the on button. That's always the first thing you do. And I'll be going back and forth. So I have a new version. It's the Smart View version. It's color. And y'all can see the keystrokes. If you don't have a calculator, you can kind of follow along with what I'm doing. Go ahead and hit the on button. And then in the top left, go to y equals. Go to y equals and type in the function into y1. Now to get, y'all are all in math type mode. So again, if you hit the caret button, it's going to put you up as an exponent. Type in the 4, and then you have to click to the right to get back down on the ground floor. Y'all probably had experience with doing that. Okay? So you double check, you triple check, you make sure you have it in there correctly. Now we want to sketch it. So the graphing window for any function that you don't know what it looks like, a great place to start is the standard viewing window, which is -10 to 10. So up here at the top, you can hit the zoom button, and then number 6 is your standard. That gives you a -10 to 10. So that's what I'm going to do, zoom 6. All right. Mine came in pretty fast. It looks like it comes in from the top. It's going to turn around somewhere off my screen, come up, turn around, and go back out. So once we hit zoom 6, we can now go in and edit the window and customize it so that it fits our graph better. So the first thing I'm noticing is I don't have to look as far left and right. So I'm going to change my X min and my X max, and I also have to look a little bit lower. So up here right next to y equals is your window. Click it, and we'll manually adjust it. Instead of going all the way to -10, I'm going to go just to -4, and I'll also go over to +4. The next one is X scale. That's how often it puts a tick mark. You could put one every 1 unit. That's fine. My Y min, I have to look lower than -10, so I'm going to put it to -20 and see if that's enough. I will leave my X max to 10, and what I typically do is I turn my Y scale off. I turn it to 0. I don't care to put tick marks on the Y axis. I don't really need them. It just kind of makes the graph kind of ugly if we have too many of them. Everything else you can leave in the default settings, okay? So now if I hit graph, I've manually adjusted the window. That's looking better, but I still need to look a little bit lower, don't I? I don't see the bottom part of the graph. So one last time, I'll go to my window, go to Y min, and let's try maybe -30, okay? And there you go. So now we have a really nice viewing window for our graph, all right? So we started with zoom 6, and then we kind of went from there and manually tweaked it so we see this beautiful picture. All right, so the graph comes to the top, turns around, goes back out the top. How many local extrema do you see here? That means local maximums or local mins. I spy 3, right? How many local minimums do you see? 2. There's 2 valleys, and how many local maximums? Just the 1, okay? Let's go ahead and find them on our calculator. They're not going to be at really nice numbers, so we're going to find them using the calculator. Let's just go from left to right. We'll do this guy first, all right? So from the graphing screen, if you hit second trace, that's your calculate menu. So just look at that like you would be like at the drive-thru at Chick-fil-A looking at their menu, like, these scrumptious choices. What do I want to choose? Guess which one? We're going to choose minimum. So you either type in 3 or you scroll down to 3 and hit enter. The calculator is going to ask you for 3 pieces of information. The first thing it's going to ask is for a left bound. So you can see your cursor scrolling. If you hit left on the directional pad, you can cruise the curve until you are to the left of that low point. I got a visual that I'm to the left of the low point. If you want to get a little bit closer to the left, that's fine. If you want to move a little bit farther away, whatever, you're to the left, hit enter. Now my calculator is a new version, so it puts a vertical line. If you don't put a vertical, if it doesn't have a vertical line, you should have this little arrow here. That's your left bound. All right, now it says right bound. So click to the right until you know that you're to the right. I can visually see that I'm coming up, so that's good. I'll just hit enter again. Boom, mine puts another vertical line. Yours is probably just going to have another arrow. So what I'm telling the calculator then is in between these two x values, I think the local minimum exists. And so the calculator is going to scan all of its y values that it computed in making the graph, which is pretty impressive, and it's going to find the lowest one for you. So for the guess, you can just hit enter and use the right endpoint, or if you feel like you want to help your calculator, you could scroll back to where you think it is and then hit enter. It doesn't really matter. It doesn't speed up the process. And there it is, okay? So now all we have to do is transfer that information to our iPad. So I'm going to say in a complete sentence, and you can't see it, but I'll say it out loud and then go to it. F has a local minimum. Is that also an absolute minimum? Yes. So let's go ahead and add that. We'll say F has a local minimum and a global minimum. And let me just show you what I've written so far. F has a local minimum and then I put global in parentheses, right? Because you could just say a local minimum and a minimum. Now, do we list it as an ordered pair? No, we don't. We say it has a local minimum of y equals, and then the y value is negative 24 point. So here's where we have now for the first time a number that is not exact. Your responsibility this year is reporting to 3 decimal accuracy, always 3 decimals. And you can round or truncate. Truncate means don't round. So negative 24.057. That would be the answer if you rounded or truncated. And it occurs at x equals negative 2.056 if you truncate, or negative 2.057 if you round. Okay? I give you permission to not round. It's okay in this class if you just truncate and do not round. I noticed last period walking around, though, that almost everybody was still rounding, which is fine. You feel like you're breaking the law if you don't round, or that your teachers from, your younger age are going to get mad at you for not rounding. You can round or not round. I personally am a big fan of not rounding, of truncating. So I would list that as negative 2.056. Even if it were a 9 after there, I'd just call it negative 2.056. But I'll accept either answer. You have to be correct in the third decimal place, either rounding or truncating. Okay? So there's the lowest y value on the graph, and it's also a local minimum, and it occurs at that x value. All right, moving from left to right. The next guy would be this guy here, and he's going to be a local what? Max. So go back to your window. Second trace is your calculate menu. And now which one do we want? Number 4, we want maximum. It doesn't say local max on the menu, but it's finding the maximum value on an interval, an open interval that we're putting. So am I to the left? Yeah, it looks good. I'll hit enter. And now I'm going to scroll to the right until I know I'm past it. So notice again, we're finding local extrema. The calculator is asking us to define an open interval that contains it. For your guess, you could just hit enter. Let it be the right endpoint. It doesn't slow the calculator down or speed it up if you move. So you can just hit enter, enter at the end. So there we go. Now we'll say F has a local max. Well, I'll use relative this time. Either one has a relative max of y equals positive 1.323 or 324. I'm going to just write down the truncated answer, but you can put 324 at x equals 0.455 or 456, either one. All right, so here's what I wrote down. F has a relative or local max of y equals that at x equals that. Would it be the same if I just put F has a max of? No, because that would imply what type? Global. Good. So you can say relative or local. Is that also the absolute max? No, that's not the absolute max. As you can see, if I go to the right over here, I have a lot of y values that are bigger. So that's not the global max. All right, this guy over here is next. He's a local min. So one more time, second trace number 3. And now to the left, that looks good. Hit enter. The open interval containing it will move to the right. I can see it's coming up. That looks good. Enter, and then enter for your guess. All right, so now we'll write that again. F has I'll go back to local this time, a local minimum of y equals negative 1.766 at x equals 1.600 if you truncate, 1.601 if you round. Now, this is where I saw people last period writing 1.601, okay? If we do truncate and call it 1.600, do we need to write those two zeros down at the end? Yes, we do. We do, because it's part of the accuracy of the number. Unless it's zeros forevermore on the back end of the number, you need to write those, okay? What that would be like 3/2, right? 3/2 is a terminating decimal. It's 1.5. You do not have to write 1.500. If it terminates prior to 3, just write however many decimals it has. But this is not zeros forevermore after it. So I think that's why last period a lot of people, because it was a 9, they just wrote it as 1.601. That's fine. I don't care. Just 3 decimal accuracy, 1.600. It feels wrong. It feels naughty, but it's okay. I'm telling you it's okay. I'm giving you permission to not round. It's called whatting? Truncating. And you can remember that. Truncating means to chop off. Like think of an elephant with a trunk and then chop off his trunk. Yeah, what? Don't do that to a real elephant. And leave those rhinos alone too. Okay? All right. Is that also the absolute minimum? No, because we already found him over here. So we found all the local max and mins, right? And we did stumble upon the absolute or global minimum. What's left to discuss? The global maximum. Does this function have a global maximum over its domain? If I don't specify an interval for you, you consider the entire domain of the function. Is there a global max? No, there is not. Because if you look at the two end behaviors, both of them go to where? Infinity. And infinity is not a number. So this function is bounded below by the absolute minimum, but it's unbounded above. So you could just say no max or no global max or no absolute max. Either one of them. No max. No maximum. Okay, that's good. There's no max. Now, notice we can actually find the range of this function now, can't we? What would he say the absolute minimum value was? Negative 24.057. So the range of this function would be negative 24.057 with a beefy bracket on it, comma, infinity. Yeah, there you go. All right, cool. The range of a function is always going to be between the absolute min and max, if you have a min and max. We just found one that doesn't have an absolute max. All right, so far so good. You think you can handle that? With a calculator, it's not that bad. Now, if you go on to take calculus next year, this is pre-calculus, we will be able to find those x values without a calculator. Yeah. But we need to know calculus to do that. That's one of the powerful things about calculus. You can find the location of your local max and mins pretty darn easily without a calculator. That was one of the reasons that it was invented by Newton and Leibniz back in the day. All right, so we are going to stop right there for today. Tomorrow we'll pick up with B. We'll have the calculators on our hand again, and I'll probably let you just run with it, and then we'll check your answers. So if you want to put your calculator back now and bring yours tomorrow, that's fine. You're welcome to use mine. Yes, yes.